Okay, so in this problem, we want to find both roots of each expression. And what do I mean? Well, typically, let's say I wrote the square root of 4. Well, when you see it in this form, typically what they're asking for is only the principal root, right? Which is 2. 2 is called the principal root because it's the positive root. And typically, that's only what we look for. However, it could also be what? Well, negative 2, right? Because 2 times 2 is 4, but so is negative 2 times negative 2. It's also 4. So essentially, these are both roots for the square root of 4. And to clear things up, the sign is the radical sign, right? The number inside, sometimes referred to as the radicand. And sometimes you can tell quickly that they want both the positive and negative root. There's something like this. They'll put positive and negative in front of it to help imply that, hey, let's get both roots there. But anyway, in this problem, they're clear. They want us to find both roots for each of these. So what do we do? Well, for 9 then, both roots, we get positive and negative 3, right? Of course, because 3 squared is 9, but so is negative 3. Negative 3 times negative 3, right? That's equal to positive 9. 16 to the 1/2 power is a shorthand way of writing the square root of 16, or the exponential way of writing it, right? That half power refers to the second root, and the answer here is plus or minus 4 for the same reasons. Don't be confused in this one. Just because you have a negative sign out here doesn't mean we're looking only for the negative root, right? This means negative 1 times the square root of 25. And since the square root of 25 could be a positive or a negative 1, that means that it's like negative 1 times plus or minus 5. What does that mean? Well, that means, again, we can get negative 1 times 5, right? And what's that? Well, that's negative 5 and negative 1 times negative 5, which is just positive 5. So we can get both values. Now, in some classes and textbooks, though, this might only mean the negative value of what you're looking at, right? Or they might tell you it can only be negative. Their perspective then is that you always have a negative value, and they're using this notation to show that. But you don't have to read it that way. It really depends. So you want to check in with your class and make sure you know how that's being read. So when you change the type of root, our approach changes slightly. For example, this, the third root, right, it can be written like this, the little 3 there, kind of in the armpit of the radical sign. This is asking for a number times itself 3 times that equals 8. And in this case, the answer is only 2, right, because 2 times 2 times 2 is 8. However, negative 2 times negative 2 times negative 2 equals negative 8, right? So it doesn't equal 8. There's only one root, and that's 2. And in fact, that leads to the next one. Here, if we're taking the third root of negative 8, the answer is just negative 2. For that same reason, that negative 2 times negative 2 times negative 2 is negative 8. But if we have a positive base with an even root, like 16 to the 1/4 power, this will lead to 2 answers, right? Negative 2 to the 4th power is 16, and so is 2 to the 4th. So there's no reason to memorize patterns. You can establish them and look at what's happening here when the base is positive or negative, when your exponent has an even or odd denominator, because you can just break this down case by case to see how these things behave. But there are lots of patterns to discover. All right, thanks.